Good morning, children. Are you able to hear me? Is the voice audible?
Yes, ma'am.
Okay. So yesterday we were talking about the concurrent fault simulation and I gave you two problems. Here for the first problem, you were required to use the test vector T naught 000 and update the fault list for the circuit. In the next pass, you had to choose T2 as 100 and update the fault list. Were you able to do any of the question or there was an issue with the questions? Okay, so I think you were able to do the questions. Let's move forward. So today we will be looking into the critical path tracing, which is the path sensitization method for identifying the test vectors. Let me begin another presentation. Now, until now, what we were doing was that we had a test vector and we tried to analyze what faults it has to detect. Now, what we are doing with critical path tracing is we are identifying the primary inputs which are critical to the circuit, which are very important to the circuit, and any change on them will bring about the identification of that particular fault. So for that, the approach will be quite similar to what we have done for propagating the fault towards primary output and then tracing it back to primary inputs. Only thing is we are now trying to find the critical paths. So alternatively to fault simulation, because for fault simulation we begin with the test vectors. We here will be taking up different test vectors. So for every input vector, we have to simulate a fault-free circuit and determine the fault. Multiple fault circuits were required to be simulated, right? Now we will choose the gate input, which is critical. Critical means important. If any change happens on that, that will result into some change in the output. So we are trying to identify which of the gate inputs are critical. If by simply changing the value, an input will be said to be critical if any change on it will bring about a change in output. For example, this is an AND gate. ठीक है, इसका एक input 1 है, एक input 0 है. So right now the output is 0 for the AND gate. Let us say the input named are A, B and the output is called C. Of the two input A and B, which one is critical to this AND gate? We will say that B is critical to this AND gate because if I change my value on B and I make it 1, then I expect my output to change. Output C जो है वो 1 हो जाएगा. Therefore, I mark this input with a dot and say this dot indicates that of the two inputs, this B input is critical. A critical क्यों नहीं है? क्योंकि A पे already 1 है. अगर मैं A की value 0 कर देती हूँ, keeping the value of B as it is, which is 0, then the input set becomes 0 0. Still for input 0 0, the AND gate will give the output as 0 only. There will not be any change. Therefore, if I make any change on A and no change in B, this is not critical to my logic gate because the output is not changing. So we are in the process of finding the critical inputs and track back those critical inputs so as to identify which of the primary inputs are critical. जिस पर मेरे को अगर कोई change मिल रहा है, then there will be a change in the primary output. राइट तो अगर मुझे ऐसे प्राइमरी इनपुट्स पता चल जाएं जो क्रिटिकल हैं देन इट विल बी इजियर फॉर मी टू यूज द नेक्स्ट टेस्ट वेक्टर नेक्स्ट टेस्ट वेक्टर में मैं इसी प्राइमरी इनपुट पर बिट की वैल्यू चेंज कर दूंगी सो दैट दिस अफेक्ट्स माय एंटायर सर्किट राइट सो आई विल चेंज द बिट वैल्यू ऑन माय प्राइमरी इनपुट ठीक है आउटपुट जो हमारा सर्किट का आउटपुट है प्राइमरी आउटपुट दिस विल ऑलवेज बी कंसिडर्ड क्रिटिकल सिंस इस पर जैसे ही कोई चेंज होगा दैट विल इंडिकेट दैट देयर इज सम फॉल्ट विद इन द सर्किट देयरफॉर द आउटपुट ऑफ द सर्किट is always considered critical. So we always move backwards from output. We try to find out which of the input is critical, right? Let us try to find the critical path for this circuit. We said that the output will always be considered critical, right? So output मेरा ये है, let's say Q. This value of Q is abhi 1. The input to this OR gate is 1, 0, 0, which can easily be analyzed that if we are given this test vector, what is the possible values on each of these nets? So 0, 0 for the NAND gate will give me 1. 1 0 for this NAND gate will give me 1. NOR gate पर अगर 0 0 है so the output is 1 and for 0 1 output is 1. Here this is a NOT gate so the output here is 0. So we'll analyze the inputs. The input is 1 0 0 and the output of this OR gate is 1. Let's not write here because we need to put the dots to identify the critical inputs. Right? So the value is 1 0 0. Now of the three input, which input is critical? जिस पे अगर मैंने वैल्यू चेंज किया तो my output value will change. Which wire, A, B या C? Which one do you think is critical?
A.
A. Because A का value अभी 1 है. If I put this to 0, then the output should switch to 0 because all the three input of the OR gate will be 0. So I mark that this A input is critical. If A input is critical, this path is also critical. Any change in this path will cause the output to change. So this path becomes critical path. Now, if this is critical and the value here was 1, which of the input of this AND gate, the previous gate, are critical? एक टाइम पर एक चेंज करेंगे हम दोनों साइमल्टेनियसली चेंज नहीं हो सकते सो इफ आई हैव द एक्चुअल वैल्यू एज 1 the input will be critical if it changes the value from 1 to 0. So if I put this as critical, this is good. अगर मैं इस 1 को 0 कर देती हूँ then the input will be 0 1 and the output will go to 0. Also the other input is critical क्योंकि अगर मैंने इसको 0 कर दिया keeping the other input 1 then also the output will go to 0. It means both the inputs of the AND gate are critical. Hence backward path हम लेंगे both the paths are critical. Any error, any fault on these paths will cause a change in the output. Fine. Let us trace back to the primary inputs now. If I look at this gate, the first NAND gate, let's say G1, the output is correctly 1. What change at input will bring about the change in value at 0 from 1 to 0 in output from 1 to 0? तो 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 दो इनपुट हैं G1 के, राइट? इनमें से कोई क्रिटिकल है क्या? इफ
मैम
आई
दो
चेंज,
critical
हाँ
हैं।
दोनों
मैम दोनों ही हैं।
दोनों ही हैं. If I put this value as 1, the input to the NAND gate will be 1 0 and the output will be 1. NAND gate है ना, तो 1 0 अगर मेरा input है, then the output will be 1. So there will not be any change. So this input is not critical. Is it okay?
यस मैम।
है ना,
Yes,
NAND
ma'am.
के लिए 0 0 0 1 1 0 1 1. NAND मतलब ये सब 1 हो गया, ये 0 हुआ. तो अगर मैंने इसको इनपुट चेंज किया तो आउटपुट में ये चेंज नहीं आया, आउटपुट इज स्टिल 1. इफ आई मेक दिस चेंज एट इनपुट, इसको 0 से 1 कर दूं, कीपिंग दिस एज 0, then also the output is 1. It means none of the input to G1 are critical. ठीक है? Let's do it for G2. G2 के लिए कौन सा इनपुट क्रिटिकल होगा? If I put this 1 to 0,
B input.
नीचे वाला है ना, the input
Yes,
with
ma'am.
value 0, yes, because if this input with value 1 is changed to 0, तो input of G2 becomes 0 0, जिससे output अभी भी 1 ही रहेगा. So this is not critical. But instead, if I put a change here, if I change the value from 0 to 1 at this input, the output will switch from 1 to 0. It means this is critical. So it means this primary input is critical for my circuit. So in the next pass, I should expect a change here that will bring about a change in the output. Right? This is the only critical primary input. Right? Now, if this is critical primary input, what possible faults can be detected? Let us say A, B, C are written over here. So D, E, F, G, H, I, J, K, L, M, N, O, P, Q is here. Let us say this is R. Now, if this is the critical path identified, the red wires, what are the possible faults that will be detected using this test vector? The first fault that will be detected is here at G. So if G is stuck at 1, if there is a faulty 1, then this critical path will propagate it to the primary output. Therefore, the fault that is detected is G stuck at 1. What other fault? Move forward. This is your wire N. Wire N per actual value is 1. And due to the fault propagation, the value may go to 0. Therefore, N0 is the next fault that can be detected. Right? Similarly, A0. Here, no fault will be detected because the value was not changing. Then A is already detected and last fault is at the output, which is Q0. So this input test vector will be able to detect the faults G stuck at 1, N stuck at 0, A stuck at 0 and Q stuck at 0. Okay. If I change this vector to 0 0 1 1 0 0 1 0 1 and 1, then you will have the other faults that will be detected. Simply apply the logic values for the non-faulty circuit and then trace back from primary output, find the critical paths that will determine the faults which are detected. ठीक है, अभी मुझे बार बार सर्किट सिमुलेट नहीं करना पड़ा. सिर्फ एक बार I simulated the non-faulty circuit to calculate the value on each wire. Then considering this as the critical, the output as critical, I traced back my critical path. जो critical path होगा उस पर the faults will be detected. Is it okay? If my circuit has more than one output, अगर मेरे circuit में more than one output है, then I will have multiple critical paths. ठीक? This is yet another way for analyzing the circuit. Any problem in any of the simulation and the critical path tracing? Okay. Now, after this, we begin with another section of the syllabus, which is ATPG. ATPG stands for Automatic Test Pattern Generator or Generation. अभी तक हमारे पास क्या था? कुछ सर्किट था. We were giving the test vectors T1, T2, T3 and so on, and we were analyzing the set of faults which were detected using different simulation methods and critical path tracing method. Now the question appears, how to choose this T1, T2 and other test vectors? Because if I say that I have an adder circuit or 64-bit adder, then ये 64 lines हो गई for A, this is 64 lines for B and 1 line for C in. I'll get some output for sum and carry. This is again 64-bit, this is 1 bit. Okay. So what are the possible number of test vectors that I can have? If I have 64-bit line here, then 2 to the power 64 will the possible cases. Is it so? अगर मेरे पास 64-bit adder है, then I will have 2 to the power 64 test patterns. Of this 2 to the power 64 test patterns, which test pattern should I use so that in the initial tests only most of the faults are detected? That becomes the problem now. So now we have to find out which are the most suitable test patterns which should be simulated first. We try to do this automatically by using different algorithms. Automatically means we use different algorithms to identify which one is better. ठीक है? जो मेरे combinational circuits हैं, these are tested with two approach. The first one says functional test. As the name suggests, functional test क्या करेगा कि मेरा जो box है, जो मेरा circuit है, this is working properly or not. Is it functioning properly or not? It is checking just that. So for that, all the possible test patterns will be given at input. Say here 2 to the power 64 test patterns will be given to the input. And for every test pattern, I check both the outputs. If the outputs are coming correct, we say कि the circuit is working properly. ठीक है? So this is quite cumbersome. इतने सारे tests मुझे करने पड़ेंगे. ये तो when it is 64-bit and circuit अगर छोटा सा एक या दो logic gates है, then it will take less time. But if the circuit is quite cumbersome, then it will take longer time. So for that, we work with structural tests. Sorry. Structural test means we work with the minimal set of stuck at faults or bridging fault, जो भी हमारी faults हैं, we consider those faults and we choose and we find the minimum set of stuck at fault at each line of the circuit and try to analyze them. So this will reduce my number of test patterns. This we discussed before also. To identify the minimal set of stuck at faults, we undergo collapsing. कौन से दो तरह की collapsing करते हैं हम? What two types of collapsing did we study?
Equivalence and dominance.
Yes. Equivalence collapsing पहले हम करेंगे, जो भी fault equivalent है उन faults को हम suppress कर देंगे. फिर उसके बाद हम what was the other? Dominant faults. The dominant faults will be suppressed. So we will get a minimal set of faults that need to be analyzed. अगर मैंने number of faults कम कर दिए हैं, then I will automatically reduce the number of test patterns. How do I reduce? क्योंकि अब एक test pattern जरूरी नहीं है एक ही fault detect करे, it can detect multiple faults. So now I will choose the first test vector which will detect most of the fault so that the coverage is large, right? Then I'll choose another test vector which will cover significantly other faults which T1 has not detected. ठीक है, ज्यादातर वो वाले फॉल्ट्स हो. सो इस तरह से अगर हम चलेंगे, देन द मिनिमल नंबर ऑफ टेस्ट वेक्टर्स इफ अप्लाइड विल हैव द मैक्सिमम कवरेज. However, the coverage is around 60 to 70% and that is sufficient, considered sufficient, right? So for that, the first algorithm that we'll be doing tomorrow is referred to as D-algo. For this D-algo, we need to understand singular cubes, which we will do today, and then we'll do the algorithm tomorrow. What are singular cubes? Singular cube is simply a compressed version of the truth table for any gate. For example, let us try the AND gate. AND gate के inputs है मेरे A, B, and then I have the output as C. 0 0 0 1 1 0 1 1. Output is 0 0 0 and 1. So when I try to find the singular cube, then I combine the rows in such a way that I introduce don't cares and reduce the number of rows. For example, here I can write this truth table as, look at the first two entries. If I try to combine these two entries and I am sure that A is 0, B can be don't care, the output will always be C. So the first entry in my singular cube will be 0 x 0, right? The next, try to combine this and this. If I choose these two, then the value of B is 0, A is don't care. So x 0, but the output is still 0. Right? I cannot combine the second and the third row because ऐसा नहीं है कि don't care पे 0 ही आए. And the last entry would be 1 1 1. So I reduce one line for the actual truth table to represent the AND gate. So this is referred to as the singular cube for AND gate. Similarly, I can determine the singular cube for OR gate. One 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 0. I try to combine the rows where the output is same. So the equivalent would be, if A is 0, B is anything, don't care, then C is 1. right? Combine the first and the third row. A becomes X, B becomes 0, but the output is still 1. For both the, sorry, something wrong here. I wrote it wrong. How will I combine now? 0, 0, 0 to as it is rahega because it cannot be combined. No other entry for output equal to 0. I can combine the second and the last row so that if A is don't care, B is 1, then the output will be 1. Similarly, third and fourth row. So if A is 1 but B is don't care, my output will again be 1. Right? So this is my singular cube or primitive cube. ठीक है, primitive cubes पहले पढ़े हैं डिजिटल में? डिजिटल इलेक्ट्रॉनिक्स में पढ़े हैं? नहीं पढ़े हैं? Okay. So in this way, we will be writing the primitive cubes or the singular cubes for all the logic gates that may come across us in the circuit. 2 input के लिए भी लिख सकते हैं, 3 input gates के लिए भी लिख सकते हैं and every other possible gate. ठीक है? We call it PC, primitive cubes also. Now
ये
the
मॉरिस
other
मानो में है क्या मैम?
नहीं, ये उसमें बुशनेल में दिया होगा. Other than this, we will now use 5 variable boolean. 5 वेरिएबल बुलियन मींस अभी तक आपने वेरिएबल की वैल्यू क्या पढ़ी है? या तो वैल्यू 0 होगी या 1 होगी या डोंट केयर होगी. बुलियन अलजेब्रा में हमने ये देखा था. नाउ वी इंट्रोड्यूस टू मोर थिंग्स, d and d bar, where 0, 1 and don't care, they give me the actual values, and d and d dash will be used to simulate the faults. So that this d indicates, let us say d corresponds to 0, 1. It means the actual value is 0, but the faulty value is 1. D bar will be complement of this, which simply indicates that the actual value is 1, but the faulty value is 0. ठीक? 0 का मतलब actual value भी 0 है और faulty value भी 0 है. So no change in the value. 1 means faulty, non-faulty, it is all 1, no change. Don't care means again no change, no fault. Agar input is X, then the faulty input is X, the non-faulty input is also X. And I need to work for their intersection during the algorithm. Intersection simply means that what is the possible Boolean algebra for these. So I have the possibility 0, 1, X, D, D bar. 0, 1, X, D, D bar. 0 intersect with 0 will always give you 0. These are the rules which you need to remember. Just a minute. Okay. So 0 intersects with 0 will always give you 0. 0 intersection 1. It means the actual value was 0, but it is read as 1. So here the actual value is 0, but it is read as 1. So we call it D. अगर कहीं ऐसा हो रहा है कि actual value is 0 but the read value is 1, then we indicate this with D. 0 X. This will always be X. 0 intersection D is not defined because D itself indicates a fault and opposite or the complementary is D bar. Therefore, this is also not defined. What will be the intersection of 1 with 0? Actual value is 1, but it is read as 0. So this is D dash. 1, 1 will remain 1. 1 is 1. Then 1 with don't care will always be a don't care. No, 1 and don't care. The value will be preserved with don't care. Don't care will always preserve the value. So 0 intersection don't care is 0. 1 intersection don't care is 1. 1 intersection D not allowed. 1 intersection D dash not allowed. X intersection 0 don't care intersection 0. This will be 0. Don't care intersection 1, the value preserved. Don't care, the value preserved. Don't care and D. So the value preserved remains D. Don't care D dash is D dash. Right? D intersection 0 not defined. D intersection 1 not defined. D intersection don't care will always be don't care. No, D, the value preserved. DD will be D. And D intersection D dash can be considered, cannot be considered. Simply we'll discuss the reason later. D dash intersection 0 is not defined. This is also not defined. D dash intersection X will be D dash. D dash intersection D will mark it as a star for the time being. And D dash intersection D dash will be D dash. This star indicates that I can change D to D dash. Provided if I make a change, I should make this change consistent in my calculation. Right? It is not always necessary कि D का definition is 0/1. You can anytime change the definition of D as 1/0, which means the actual value is 1 and the faulty value is 0 is indicated with D. But if this is so, then D dash automatically changes to 0, 1. Okay? We can interchange them during the calculation, but once during the calculation it is changed, we keep the change consistent. Fine. Now using this intersection for the 5 variables and the primitive cubes for the logic gates which lie within the circuit, we will apply the D algorithm and we try to find out what is the test vector that is used. Right, we'll take up one fault and we'll try to identify the test vector. What test vector will indicate that fault or detect that fault? Okay, we'll do it in the next class. Any problem in today's class? We'll revisit this primitive cube and the algebra when we work on the circuits for D algorithm. This is chapter number 7 from Bushnell. Critical path tracing is not there in Bushnell. This is in the other book. I don't exactly remember how to spell the name. This is in your reference.
Abramovich.
That book. The critical path tracing is covered from that book. Now tomorrow we'll get into detail with chapter number 7 in Bushnell. ठीक है? So that is all for today. Quiz का time क्या रखना है on Sunday? 10 a.m. is fine.
I'm 12.
12. Okay. So at 12 noon on this Sunday, that is 13th, you will have the quiz for fault modeling and fault simulation. Critical path tracing will not come in that, only till fault simulation. It will contain numericals, so please keep paper pen ready. ठीक है? So that is
Ma'am,
all
how
for
many questions?
10 questions, 20 minutes. It won't be lengthy, but you will need paper pen to work out certain problems. ठीक? Okay, so that is all for today. You may leave. I am ending the meeting now.